Welcome to the Desktop and Application Virtualization Best Practices in Horizon 6 Bootcamp session. My name is Jim Yanik, and I'm an end-user computing architect at VMware. In today's session, we'll cover a couple of the new features of Horizon 6. We'll talk about the phases of deployment, all of which are necessary for a successful Horizon 6 deployment project. We'll focus on assessments and their importance in gathering empirical data about the current environment. We'll talk about the concept of defining use cases, how they're defined, and why they're important to define. We'll talk about pilot phase. This is a great phase for getting to understand the complete environment, putting in operational practices, as well as deployment practices. We'll talk about operational best practices, including backup and monitoring, and we'll cover some tools and resources that are available. One of the powerful and much anticipated features of Horizon 6 is the ability to deliver applications as well as RDS desktops and full VDI desktops through View. So now we can deliver individual applications to end users, which they can access through the Horizon client, whether it's on a full Mac or Windows client with a seamless Windows experience and interaction with the local client itself, or full screen access on iOS and Android devices. How that interface will look is going to depend on the individual device, but it will be provided through the Horizon client, and we'll be doing this over PC over IP. So we have all of the user capabilities and all of the video capabilities that PC over IP gives us. Some advantages of this is a lower TCO. So now, instead of giving a full VDI desktop to a user, I can give them single applications if that's what they need for their use case, and potentially use RDS Cal licensing that I already own. And as I mentioned already, very high performance user experience. We're using PC over IP, and these clients, these applications can be accessed through the Horizon workspace as well as through the standard Horizon client. Another new feature of Horizon 6 is Cloud Pod architecture. This allows us to federate View pods across sites and within a data center between View pods. This gives us the ability to extend the size of View pods past the 10,000 user limit, and also allows us to provide a global entitlement to users across sites. So we use a global LDAP replication through ADLDS that is very WAN friendly, that allows us to replicate directory information between pods and entitle users globally. So if I have a user whose primary data center is in Chicago, I can also provide them a desktop that is being hosted in New York City. If in the case of a disaster, for example, I lose a site, the user will continue to just access their View desktop in the same way they've always accessed it. Cloud Pod architecture, along with load balancing, uses a global namespace, so there's really no change to the user for a DR scenario. Cloud Pod architecture can also be used, as I mentioned, to extend the sites beyond the 10,000 limit, as well as to provide a global or geo-roaming desktop for users. Next, let's talk about the project phases for success and failure. There are 5 phases to a successful deployment, and we believe this to be a critical path. These are the phases that our consulting engineers, our architects, and our partners use to help customers to deliver a successful Horizon environment. The first phase is to do an assessment. This way we understand our current situation, what the physical environment looks like, what kind of numbers we've got from a baseline standpoint around disk IOs, application usage, etc. And we also understand the business needs of the groups that we're trying to provide a Horizon environment for. In the Discover session, we start to move beyond our own group and do knowledge transfers with the other organizations within the company that are going to be both accessing and helping us to deploy the Horizon environment. We build our use cases and understand what each individual user needs, and we implement a POC. In the plan and design phase, we begin to understand our operational requirements, how things will run day to day. We put together a full implementation plan as well as a detailed design of what we're going to deploy. In the build and test phase, we start to implement the solution. We do performance testing, we validate the design, we identify potential risks, and we update the design until it's finalized. We also start a pilot in this phase and expand the user groups that are involved beyond the POC. In the optimize phase, we're going to do environment tuning and optimization, and we're going to evaluate everything that's going on against our current best practices. The way to ensure a troubled deployment or potentially a failed deployment is to skip the assess phase. This is a problem that a lot of customers have encountered, so we like to talk about it in detail. This makes it so that we don't have a baseline, we don't understand what the requirements are for our customers and our use cases, and often miss important requirements that will be a problem as we go into the design and build phase. And we have poor assumptions. We don't fully understand what the application profiles look like. What are the highest use applications? We don't necessarily understand what the storage I/O requirements are. And usually we undersize rather than oversize. What this tends to lead to, and the big lesson we've learned, is when there's no assessment, it equates to lots of support calls for you as the customer. Let's talk about the assessment phase. This is really where successful deployments start. In the assessment phase, we gather up a lot of empirical data about our current physical state. We understand the existing vSphere infrastructure, how it's set up, what we can use for the Horizon project, or what will need to be built in order to support the Horizon project. We understand our network situation, our full WAN infrastructure, what sites are remote, how many mobile users we're going to have, and really understand what the use cases are around the LAN and WAN side. We get a lot of information about our physical desktop environment, what applications are being used, what OS versions, what are our usage patterns, when are the peaks and valleys. Some important things that a lot of customers overlook during the assessment phase is this is the perfect time to start to identify the subject matter experts in all the essential areas that will impact the Horizon project. Storage, networking, security, and vSphere are just some of the areas that are important to understand. Also, we need to identify and interview our key stakeholders early in the process. We need to completely understand the user use case. We need to understand what are pain points for them, what regulatory or security requirements their individual areas or departments need, and what departmental constraints there are, special things and special needs that we need to know about each individual use case. We also need to get a good understanding of the project timelines. When do things have to be delivered? Do they have to be delivered by a specific date? And also, how will we identify our pilot users? It's very tempting to just pick the IT group and go with them, but it's a very bad representative of what the overall organization is going to be within the environment. We want to try to get pilot users in each of our use cases across different areas within the company. Assessments are very important. We use several tools to do assessments. From Liquidware Labs, Stratosphere Fit, and Lakeside Software are two that we've used quite successfully in the past and that our partners and customers have used. It's the best way to gather empirical data on the user environment. It gives us things like top 10 applications by CPU resource, what applications and what users are heavy storage I/O consumers, and where are our high latency, slow WAN links that we need to be aware of in order to be able to deliver a decent user experience across those links. It also helps us to identify user groups by use cases, to start to stratify our users. Who are power users? Who requires 3D graphics or heavy media? And where will peripherals and what kind of peripherals will be required? This physical empirical assessment is not a precise picture of what virtual will look like because we do a lot of optimization within the Windows desktops. And there are two tools that we offer to help with optimization. First of all, we've published a Windows 7.8 optimization guide that gets updated fairly frequently. There's the link to it. And we also have on our Flings site on labs.vmware.com a VMware VDI OS optimization tool that will automatically go through and optimize a desktop, either based on a template that we specify or based on a template that you can customize. Important metrics to make sure to capture during the assessment phase include understanding the top 10 or 20 applications and understand a lot of information about those applications. Who's using them? What versions are being used? How much CPU, storage I/O, and memory are those applications really taken as a percentage of the overall usage of applications? Where are my users? understand where they are in terms of subnet structure, if they're across WAN links, really understand not only the network latency, but the available bandwidth to make sure that we have the bandwidth we need to deliver a satisfactory user experience to those users. A lot of customers have sort of cut the corners on this step and tried to implement things across network WAN links that just really weren't suitable to do across those WAN links. So understanding that and understanding how PC over IP works and how much bandwidth it's going to be using is very important. Get a good feel of CPU usage, average and peak across the environment. This helps you to size how many ESXi hosts you're going to need to host the desktops. In the case where you have shift workers, for example, understand how many users are using a specific device. And also make sure you understand all the operating systems, what OS version they've got, what service pack they have, and also if you're going to move to a new operating system, determine what operating system you're going to be standardizing for the new environment. Next, we talk about defining use cases and the importance of defining use cases to stratify our users. This is very important to the design phase. We must understand how our users are stratified and what we're going to be able to deliver to those users. It's very important to understand the number of use cases that you're going to deliver in your design. The more use cases you introduce, the more design complexity you introduce. So understanding the minimum number of use cases and understanding where you can potentially collapse a sub-use case into a major use case to deliver fewer use cases is going to make your design that much easier to implement. In each use case, you really need to determine exactly what's required to meet the needs of the end user. You've gathered a lot of data during your assessment phase. You've pulled information about each group of users. You've talked to stakeholders. Now you need to take that and create use cases from that. So some examples of use cases we very commonly see. A factory worker who may be accessing a couple of applications to monitor an assembly line from a PC that's on the assembly line, or more commonly now with a mobile device that they can walk around and inspect the assembly line with. A mobile user is going to have very different needs. Somebody who doesn't get to corporate much, who is always working remotely, maybe carries 2 or 3 different devices to access their applications. They're going to have some different requirements in terms of printing and in terms of WAN bandwidth. We see a lot of customers implementing offshore BPO with Horizon, so business process outsourcing in places like India and the Philippines. In these kinds of situations, there's a lot of latency in the bandwidth that's available, and there's a limited amount of bandwidth because these long-haul connections are fairly expensive. So completely understanding what the work profile is going to look like, how much bandwidth that's going to consume, and how much bandwidth is available is key to having a successful deployment. We've had plenty of customers who've cut corners on the assessment phase of this and have run into major problems trying to implement. And finally, another example would be an engineer or designer who's going to need a machine, a virtual machine that's probably got more processors, more RAM, and almost certainly 3D capabilities. So we need to design for that and define those use cases properly. When I put together that use case specification, it needs to include each of these items. So we need to include that user category. So for example, our factory worker, our field salesperson. What's their workload profile going to look like? A factory worker is going to have far less workload in terms of CPU, memory, and disk than a CAD architect is likely to have. What are the application requirements? Not just the list of applications, but do they need audio-video redirection? Do they need other USB redirection? Are they doing 3D? What sort of access requirements are in the environment from a security standpoint? Am I going to require 2-factor authentication? Are users going to leverage the current corporate VPN or some other methodology? And where are they? Is it a home worker, somebody in HQ who's on the local LAN, somebody offshore, or somebody in a branch office? And then finally, what security restrictions are you going to place on those users? Are you going to not allow them to do USB device redirection in order to potentially take files out of the corporate network? Are you going to turn off clipboard functionality so they can't copy and paste between their endpoint and the virtual desktop? And are you going to allow printing? Some other considerations around use case, and these aren't an exhaustive list by any means, but it's just to give you some ideas. So for example, if I've got a user that's got network-based profile user data, maybe they're using roaming profiles or they're using our virtual profiles or a third party, probably a linked clone non-persistent desktop is going to work for them. If my user data and profile is stored locally, or my user needs to install application locally, this could be an example of a dedicated, full clone desktop with a persistent disk. Do users need to go offline or mobile with the desktop? Potentially, this is a use case for Mirage. Does a user require multimedia applications or video? Now we have to look at 3D capabilities, both shared graphics adapter and dedicated graphics adapter potentials, or is this potentially another Mirage endpoint, something I'm going to manage the image on, but I'm not going to deliver through a virtual desktop? And then some other things that might require a dedicated desktop for that user. Do they have a custom OS build? Are they using an application that simply cannot be virtualized and has to be installed directly? Or do they require more memory or more CPUs? Some of the examples we've given, like for example, the 3D design user is probably going to need a dedicated desktop because they're going to require more memory, they're going to require a graphics adapter, and they're probably going to require more CPU. So then when I'm designing my pools, I want to map my use cases to my desktop and application pools and policies. So some things that I need to include in there are organizational unit GPO settings, user persona management. How am I going to take on patching, application performance requirements, and desktop specification? All of these things need to be taken into consideration when I'm building that pool. So in a lot of cases, we build pools for use cases. And then I have to decide, am I going to use linked clones or full clones? Is it going to be a dedicated assignment or a floating assignment? I also have a lot of capability now and a lot of flexibility with Horizon 6 in using RDS desktops or application pools. For use cases that really don't require a virtual desktop, maybe they just need to run an application or two, or I have individual applications that are provisioned through View as a pool. These are examples of people who potentially would not need a full virtual desktop but could use RDS instead. And the way this works within Horizon 6 is I have a set of RDS hosts that are brought into View as either individual hosts or a farm of hosts, and on those hosts all my applications are installed, either installed to the base of the machine, brought in through ThinApp, or brought in through other mechanisms. I'm able to take those pools into Horizon through the View Manager and add those as application pools that look much the same as a desktop pool, and then I can entitle my users to them so they can run them on whatever device they happen to be using. Now let's talk about the pilot phase and some of the best practices involved in that. When we begin the pilot phase, it's very important to get a representative cross-section of users from across the organization. These users should represent each one of the individual use cases that you're trying to deploy. We've had a lot of companies who really focus on IT staff and maybe a few users here and there. It's important to avoid that temptation and to really get users who are part of the actual user base and who are going to represent each one of those use cases. It's also important to, during the course of the pilot, to invite feedback, to maybe have surveys that users can fill out to talk about their user experience and what is and isn't working well. It's also very important before starting the pilot to define the success criteria. We don't know if the pilot's successful unless we know exactly what we're trying to test out. And we want to include both administrative and user tests. In addition to the users giving feedback about how their user experience is, which is really important, we want to make sure that we're testing out administrative processes, things like deploying desktops, recomposing desktops, etc. We also want to measure against our use case definition. When we define the use cases, this is something that we're going to use during the pilot phase to make sure that we can check off all of the functionality that the users require in order to get their jobs done. And we also need to get IT operations very involved in this phase. We really want them to lead here because part of what's going to happen is knowledge transfer, and we're going to start to develop our operational processes for rolling out the View environment. A couple of best practices in terms of the pilot. We want to validate our implementation procedures. So we want to make sure that everything that we plan to do actually works. However, we're planning on deploying hosts and other infrastructure needs to be proven out. We need to make sure that those procedures are not only working, but are well documented so that other people can carry on. Also, part of the pilot should be using real licensing and SSL certificates. Using self-signed certificates is not going to work in this phase because we want to make sure that The devices that are accessing the environment are not only able to access the environment with the certificates that they have, but that everything is secure during the course of the pilot. Another big important thing here is to make sure you're really communicating well with the rest of the organization, submitting change requests in good timing. So getting things like IP addresses, host names, certificates in advance, making sure storage volumes are ready to go, working with the groups that are responsible for AD groups, permissions, and group policies, making sure service accounts are established and maintenance windows are established. Cross-functional communication is key to a successful pilot. Now that we've completed the pilot, let's talk about some operational best practices. Let's talk about some configuration best practices first that help to optimize the environment. First, we recommend that you turn on View Storage Acceleration, also known as the content-based read cache. This is on by default. What this does is it reserves some RAM in the ESXi host that acts as a read cache. So anything that needs to be accessed from the cache happens very quickly because it's in RAM on the host, so we don't even have to go back to the cache on the array. So this really helps during boot and login storms to drastically reduce the IOPS. We've seen reductions of 75 to 80% in IOPS during those times. We also recommend you turn on space-efficient sparse disks. This is ideal for linked clone environments. What this does is it goes in and cleans up unused space within those VMDKs without having to do a recompose. So one of the things that typically happens when we don't do recomposes for a long period of time is there's just a lot of wasted space on the disk. So this goes and cleans up that wasted space. It's not currently supported for virtual SAN. We also recommend that you set memory reservation at 100% so that we're not using virtual swap on the host. In terms of connection servers, one thing that's very common is we see a lot of customers who will configure these for less than the 10 gig recommended RAM during a POC or a pilot because they're not going to scale up to the 2,000 users that potentially a connection server can do. But what happens then is the connection server actually has to be reinstalled when you go into production. So our recommendation is to put that minimum of 10 gig of RAM into play right from the beginning. And we also recommend, in terms of connection servers, use a pair for internal access and a separate pair of connection servers for external access, either paired with security servers or with a load balancer like an F5 in front of them. The reason for this is then we can separate the way access happens, and we can also separate the requirements around things like two-factor authentication. Maybe internal users don't require it and external users do. Security servers are there for external access. Using the PC over IP secure gateway allows us to give access to those View clients when they're not on the desktop subnet. And finally, just some information on RDS hosts. RDS hosts are obviously new to View, but they're not new in the IT world. So your configuration is going to vary depending on your workload, but a good starting configuration might be 4 virtual CPUs, 64 gigs of RAM, and about 50 connections. Again, this is going to vary, and you need to do some sizing around this. In terms of backup, this is something that gets neglected often, and there are a number of components you need to be aware of that need to be backed up. So first of all, we need to back up our SQL Server so that we're doing regular View Composer backups, and also the View Events database, just so we can keep that information consistently. Also, just as a tip, make sure your logs are truncated if SQL database are using the full mode. In terms of the pod, you're going to want to configure a daily schedule with View Administrator to back up the pod to file. You only have to do this on one of the connection servers in the same pod. So if you've got 3 or 4 pods, you'll need to do this 3 or 4 times, but you won't have to do it on every single connection server. Also, ADL LDS needs to be backed up. It gets replicated with Active Directory, and you can manually back it up using the VDM export command line utility. And then virtual desktops, in particular, our master VMs that we're using to create link clone desktops and our master full clone desktops. Whether or not you back up the user's desktop is an operational discussion you'll have to have, but typically customers want to just make sure that those master VMs and that the full clones that we're using to create other full clone desktops are getting backed up. Monitoring is extremely important in a View environment. We see a lot of customers who are not implementing any kind of monitoring in their environment, and so when they're looking to figure out where a problem is, they're kind of doing a needle in a haystack thing because there are so many components that make up a Horizon infrastructure. So for example, if a user is calling to complain about slow access, that could come from a whole bunch of different areas. It could be the servers themselves, it could be storage, it could be latency on their WAN, and discovering that without some kind of correlated monitoring tool is really difficult. So vCenter Operations Manager for Horizon is a key part of our design. We recommend this for all of our customers. I get asked a lot about, well, how many desktops should I have before I start to consider a vCenter Operations Manager? And my response is typically, well, how critical are those desktops to you? Is it important to your users that those desktops are up? So it really doesn't matter whether it's 100 desktops or 10,000 desktops. If they're important to your business and important to your users, having some monitoring tools for those is very important. Currently, a single VCOps instance can monitor 8,000 concurrent desktops, and this just helps us understand current workloads, and I can use those metrics for optimization. It also helps me troubleshoot problems back in time. So for example, if somebody was having a connectivity problem overnight, maybe an offshore worker, I can go back and look at those statistics overnight when I come in the morning. A lot of help desks use this as a heat map and a dashboard for what's going on with operations. A very important part of a successful Horizon deployment. Finally, I'm just going to talk about a couple of tools and resources that are available. So some of these we've talked about, but I'll sort of reiterate. VMware Labs, we publish Flings. Flings are engineering tools that are not specifically supported, but are very helpful for managing different aspects of vSphere. In our case, there are a number of end-user computing related Flings. They're free, and they're great additional tools to manage the environment. One of them I've already talked about, and that was the optimization tool that's available. But there's also a Horizon View configuration tool that gets deployed as a virtual appliance and allows you to automatically deploy connection servers, security servers, and Composer, and even an AD domain controller for the purposes of a PSO or a POC. There's also a View controlled recompose script that allows you to perform controlled link clone recomposes. So it allows you to input a bunch of parameters to be able to control how a recompose happens so that you can maintain availability throughout a recompose. These are just some locations for some of these resources and also a resource on performance tuning. I hope this has been helpful. I've covered a lot of different areas that are important when planning and executing a Horizon implementation. We have a lot of experience working with customers who are doing Horizon installs, and we've come up with a lot of tips, tricks, and best practices over the course of a number of years, and I've tried to incorporate some of those in this presentation. We also want you to know that we have a wide ecosystem of partners with experience in this area, as well as our own professional services. Thank you for taking the time, and have a great day.